Welcome to the Math Record. Today I'll be covering the ICTM Regional 2016 Division AA Algebra 1, Algebra 2, which I'll be covering questions number 9, number 10, and 17. And then next video I'll be covering questions 19 and 20. Okay, so as usual, let's take time to scroll down on 20. Okay, now let's begin with number 9. Three monkeys randomly toss 24 indistinguishable ping pong balls into three containers labeled A, B, C. Each ball is equally likely to end up in one of these containers, and all balls go into one of the containers. Determine the number of distinct outcomes. The order doesn't matter. Okay, so we have A, B, and C as our containers. So let's keep A constant and then change B and C. So if A is equal to 0, if B is equal to 0 also, then C is 24, right? Now if A is still 0, this is, let's say, 1 now. Now this is going to be 23, right? So if this is 0, this is 2, this is 22. If this is 0, this is 3, that's 21. So each time this increased by 1, this decreased by 1. So as you see, how high can B go up to? Well, it could go from 0 to 24. So that's a total of 25 possibilities. When A is equal to 0, we have 25 possibilities. Okay, now let's try when A is equal to 1. If A is equal to 1 and let's say B is 0, C is equal to 23. Now if there's 1, that's 22. 1, 2, that's 21. 1, 3, and 9, 20, right? So we see the same pattern again. If A is equal to 1, B increased by 1 each time, C decreased by 1 each time. So what's the highest value B could go up to? Well, it could go from 0 to 23, right? Because 23 plus this 1 makes 24. So 0 to 23, there's 24 possibilities. So when A is equal to 1, there's 24 possibilities. So we kind of see a pattern, 25 to 24. Okay, so let's say A is equal to 2. If it's equal to 2, B will start with 0, then C is 22. If A is 2, increase by 1, this decrease by 1, so that's 21. B increased by 1, so that's 2, so that's decreased by 20. You see again, increase by 1, decrease by 1, right? So when A is equal to 2, how many possibilities are there? Well, it goes from 0, and the highest amount is 22, because 22 plus 2 is 24. So 0 to 22, there's a total of 23 possibilities. So if we keep going down for how many values for A, so from 0, 1, 2, 3, 4, 5, 6, 7, etc., our possibilities go down by 1. So 25, 24, 23, 22, etc. So, so that means basically it goes down by 1 each time. So to find the total amount, all we have to do is just add up all the numbers from 25 to 1. So 25 to 1, how many numbers are there? 25 divided by 2, so it's just arithmetic sum. And then the first term is 25 and the last term is 1. So 26 divided by 2 is 13. So 25 times 13, that is 325. And that's your answer for number 9. Okay, number 10. A ball is dropped from a height of 100 feet and it rebounds 3/5 of its height each time forever. Determine the total number of feet that the ball travels. So if a ball is dropped from 100, right, and it goes up 3/5 of its height, so let's say something like this, that means it has to fall back down 3/5 of its height. So it falls down and then bounce back up, and then falls back down 3/5 of its height. Then it bounces back up 3/5, so 3/5 of its height, and then falls back down. And it keeps doing that forever. So what is the total amount of distance traveled? Well, if you kind of think about it, we could think about it going down and then going up, right? So when it's going down, how many distance does it travel? Well, it starts with 100, and then each time it goes by 3/5. So 3/5 x. Okay, and then basically we just need to find all the distance that basically so this is like when x is equal to 0, when x is equal to 1, when x is equal to 2, x is equal to 3, x is equal to 4, right? So basically all we have to do is just sum up all those possibilities. So when x is equal to 0 to infinity. So to do this, this is an infinite geometric series. So all we have to do is just put a 0 in here. So that is 100. So the first term is 100 divided by 1 minus the ratio. So 1 minus 3 over 5. So that's 100 over 2/5, or 100 times 5 over 2. So that makes 50. 50 times 5 is 250. So we know that our first, when it's just going down, the amount of distance it's traveled is 250 feet. Okay, now let's swap into when it's going up. Well, the first one is 100 times 3/5, so that is 60. And then each time it goes 3/5, so 3/5 x. So this is when x is equal to 0, when x equals 1, x equals 2, x equals 3. So take the summation from 0 to infinity. So when it's the first term is 60 divided by 1 minus the ratio is 3 over 5. So that is 2/5. So 60 divided by 2/5 multiplied by 5 over 2, which is the same thing. So this is 30 times 5, which is 150. So the sum basically is the total distance, 250 plus 150 is 400. And that is our answer for our number 10. So basically you just need to recognize that it's an infinite geometric series where there's two of them, one going up and one going down. Okay, now let's go with number 17. P of x is a polynomial function where when p of x is divided by x plus 3, the remainder is 1. So we kind of write it in like the remainder form, basically. We have some kind of coefficient, let's call it a, times x plus 3 plus our remainder. So our remainder is 1. And when p of x is divided by x minus 1, let's call that b, x minus 1, the remainder is 3, so plus 3. Okay, determine the remainder when p of x is divided by x squared plus 2x minus 3. So p of x equals some kind of coefficient, c, times x squared plus 2x minus 3 plus some kind of remainder. So if this is quadratic, that means our remainder could either be a linear or a constant. So let's just make some remainder. So let's call that dx plus e, right? So if d is 0, then then our e is going to be our constant, which makes a constant remainder. But it could be a linear remainder too. That's why there's a dx. Okay, so how do we find dx? I mean dx plus e. Well, if you kind of think about it, we could just plug in some values for our x, because this is all p. So if we plug in p is equal to -3, so for this equation, right, we get -3 plus 3 is 0, so we know that p of -3 is equal to just 1. And then we plug in here, we have p of -3, so that's -4b plus 3. Now, that basically gives us, now we kind of plug it in here also. We have p of um, -3, right? This is -6. I mean 9, and then plus -6, which is 3, and then 3 minus 3 is 0, so c times 0 is 0, and then you plug in -3 here, so -3d plus e, and we know that -3d plus e has to equal to 1, so we know that is true. And we could also do the same thing for when x is equal to 1, because we want to make this equal to 0. So that means p of 1, I'll just write in here, p of 1, that's just 4a plus 1, and then p of 1 equals, for here is equal to just 3, and then for the last equation, p of 1, so that's going to be 1 plus 2, which is 3. 3 minus 3 is 0, so c times 0 is 0. So that's just going to be d times 1, which is x. Our x is 1, so that is d plus e. So that also gives us that p of 1, which is 3, and p of 1 equals d plus e. So d plus e is also equal to our 3. And now we could basically find our values for d and e because it's just a system of equations. So we technically don't even need to get this part or this part. I was just showing work if we need it, because all we need is basically the constants. So now from here, we could just multiply the second equation by 3 and then add to the first equation. So 3e plus an e, that's 4e, and the positive 3d cancel with negative 3d, and this 9 plus 1 is 10. So e is equal to a 5 over a 2. And now what about our D? Well, our D, if we plug in 5 over 2 back into the equation, 3 minus 5 over 2 is 1 half. So D is equal to 1 half. Okay, so now we found our values for our dx plus e. So that's got to be our remainder. So it's got to be 1 half x plus 5 over 2. And that's it for number 17. Well, thanks for watching, and I'll see you at the next part of the math record. And here are the answers for all 20 questions.